Welcome to our presentation slide. Our topic is on equivalent circuit of three-phase induction motor. So to obtain the parameters of equivalent circuit, we have to conduct two tests, that are block rotor test and the no load test.
Now let's talk about no load test. No load test for the induction motor is similar to the open circuit test of the transformer, as we have learned in the previous semester for the open circuit test of a transformer. It provides information about magnetizing branch and the rotational loss of the machine. The no load test is done by applying rated frequency and voltage to the stator winding with no load on the shaft of the machine. Voltage, line current, and power readings are noted. The input power here is measured by 2 wattmeter method, and an ammeter and voltmeter are connected as shown in the figure. The ammeter measures the no-load current and voltmeter reading gives the normal rated voltage supply. And the power at no-load P0 is the sum of rotational losses, copper losses, and losses of stator and core loss. After doing the no-load test, we get I0, which is the no-load current, and V0, which is the rated supply of voltage. Also, we know that the power is given by root 3 into V0 into I0 into cos phi. Then we can also calculate cos phi by using the formula P0 divided by V0 I0 times root 3. From the no-load current and power factor, we can calculate IC, which is equals to I0 cos phi. They are also the active component of no-load current, and we can also find IM, which is equals to I0 sin phi. They are also called magnetizing component of no-load current. And we also find R0, which is equals to V0 divided by IC. They are also called branch no-load resistance. And also we can calculate X0, which is equals to V0 divided by IM. They are called as the branch no-load reactance.
So now I'll be talking about the block rotor test. From the name itself, we can know that the rotor is physically strained so that it cannot turn. This test is done at just enough voltage to provide the rated current. Hence, the block rotor test is also termed as short circuit test. This test is done to determine the short circuit current, which is ISC, with normal applied voltage to the stator, power factor on the short circuit, the total equivalent resistance, and the reactance of the motor as referred to the stator. So from the experiment, we can find the WSC, which is the wattmeter reading. So WSC is the sum of wattmeter reading 1 and the wattmeter 2 reading. So from the WSC, we know that the formula of WSC is root 3 times VSC times ISC times cos phi. And from that we can calculate the power factor. So the power factor is WSC divided by root 3 times VSC times ISC. Therefore, from the VSC, which is short circuit voltage, ISC, which is the short circuit current, and the WSC, which is the wattmeter reading, from that we can calculate the equivalent resistance referred to the stator, which is RLE, which is given by the WSC divided by 3 times ISC whole square. Then we can also calculate the equivalent impedance referred to the stator, which is given by the VSC divided by ISC. Then similarly we can also calculate the XLE, which is equivalent reactance referred to the stator, which is given by the square root of ZLE squared minus RLE squared. Therefore, for the better understanding, we have collected the data that we have done in our practical classes on the equivalent circuit of the three-phase induction motor. Therefore, as shown in the table, we have P0, which is the sum of wattmeter reading 1 and the wattmeter reading 2, which is equal to the 340 watt. From there we can also calculate the power factor, which is equal to the P divided by root 3 times V0 times I0. And then we have the value of P0, which is equal to the 340 divided by root 3 times I0. We have 0.7 times V0, which is the rated voltage, which is 400. Then the power factor we have got is 0.701. Then we can also calculate the IC, which is equal to the I naught times cos phi, which is 0.7 times 0.701, which gives 0.4907 ampere. Similarly, we can also calculate the magnetizing component Im, which is equal to the I naught times sin phi. Then by substituting the value of I naught and sin phi, we get Im as 0.5 ampere. Then after getting the value of IC and Im, we can calculate the R naught and X naught. R naught, which is given by the V naught divided by IC, and by substituting the value of V naught and IC, we get R naught as 815.2 ohm, and then X naught, which is equal to the V naught divided by Im. By substituting the value of V naught and Im, we get X naught as 800 ohm. Then regarding the second table, it gives the data on the block rotor test. Here we have ISC, which is the short circuit current, as 1 ampere, and short circuit power reading, which is the sum of watt meter reading 1 and watt meter 2 reading, which is equal to the 135 watt. And similarly, we can also calculate the power factor. So power factor, which is given by PSC divided by root 3 times VSC times ISC. So by substituting the value of PSC, VSC and ISC, we get cos phi as 0.708. From ISC and WSC, we can calculate RSC, which is equivalent resistance referred to stator. We can also calculate ZSC, which is equivalent impedance referred to the stator. And we can also calculate the XSC, which is the equivalent reactance referred to the stator. RSC, it is given by WSC divided by 3 times ISC whole square. So by substituting the value of WSC and ISC, we get RSC as 45 ohm. Then ZSC is given by VSC divided by root 3 times ISC. So similarly, by substituting the value of VSC and ISC, we get ZSC as 63.51 ohm. And lastly, XSC, which is given by the square root of ZSC whole square and minus RSC whole square. So by substituting the value of ZSC and RSC, we get XSC equal to 44.82 ohm. Therefore, by getting all the necessary parameters to construct the equivalent circuit, so the given figure is the equivalent circuit of 3-phase induction motor. Thank you, and this is the end of our presentation slide.